Hello everyone. So last time we discussed the data side of our data set that we are going to feed into our logistic regression model that we are building to predict the class of the worker. Now let's continue our discussion to do the feature engineering to see if we need to fix or change the data in a way that we can feed into the logistic regression model. So let me just share my screen and I'm going to into the dev environment. All right, so that was the state where we left. We have already loaded the data, and in the last video we explained the data set, because like I mentioned, in order to feed the data into machine learning and get the most value out of it, we need to understand the data, because that will help us to identify which features we need to feed into our model so we can get the best out from the machine learning algorithm. Right, so we have loaded this data. That's the idle data, which is available on the GitHub. You can download it from there, and we have converted it into the temporary view. And now we are going to look at the data set. So you can see I'm just getting the first 1,000 rows. If you remember, I mentioned at a couple of instances that the best part of working within the DataBricks environment is that you can use 4 languages at the same time. It really depends whatever language suits your requirement. So for example, if I want to check the quick shape or check the quality of data and I'm comfortable with the SQL, I can use the SQL, although my notebook is still based on the Python, which I've selected, and you can see in here. The default language is Python, but I can use the SQL language as well. And even at some stage, if we want to use the Scala, which is the language to build Spark, I can use that language as well, right? So that's the beauty of using DataBricks for our big data work items, including the machine learning. So I can see the data looks good. The first 1,000 records, I can see the classes there, but the class is coming as under smaller than equal to 50K and greater than equal to 50K. And then, like you can see, the very first thing I actually check how many classes we have. So I've used the distinct class from my full table, and what I did, I got 2 classes. So that means I'm going to classify my record between one of these 2 classes, right? Is it either going to be, so once we run the logistic regression, the outcome is going to be either the person who is earning greater than 50K per annum, or a person who is going to earn less than 50K or less than and equal to 50K per annum. But if you remember, I mentioned that we need to feed the numeric information. Obviously, it's going to be either 1 or 0, because with the machine learning modeling, we need to make sure all our data is in the numerical state so we can, feed into the algorithm, because it's not the machine learning algorithms are nothing but more like the mathematical model, which takes the number, process them, and return us the result, which is obviously in this case it's going to be probability distribution between the 2 outcomes. So the highest probability is going to be the result that the model is going to predict for us. Now, let me quickly check that is the data is balanced from the other attribute perspective. Now, in here, you need to remember, and we'll see if we can discuss these, because these are more like statistical concept. If you don't understand that, still fine for you to use the machine learning algorithm and benefit from them, because understanding them will obviously help you to get more grip on your model. But if you don't know, you're still able to drive the whole model. It's the similar way, like if you don't understand your engine of your cars, that should be all right, because you can still drive. The skills of driving is different from the autonomy or the engineering of the internal mechanics of the car, right? So same analogy apply in here, that if you can understand some part of the modeling or some part from the mathematics and statistics, that would be great, because that will really help you to open and dissect. But if you don't, that should be all right as well, right? You can still run the model and get the benefit from your machine learning algorithm. All right, by saying it, I can see I have 6,000 plus records as a male. We have a small number from female perspective. Like you can see, we almost have, uh, no, I think the other side is fine. Yeah. But what I can see, there is an imbalance between two classes. So male, female is fine. The data is balanced between male and female. But what I'm seeing in here, the very first observation I got, that the classes are not balanced. So you can see we have imbalance data. So there are multiple techniques we can, upsample the data, or we can downsampling the data to to balance it out, right? So that's something you need to remember for future models. All right, now let me further. So if you want to further dissect, so you can see I'm actually dividing it further by age. I'm just checking. Okay, the age group is coming all good. In this exercise, I'm not going to actually put some mechanics on age. We have bunch of values. Like you can see, we are getting the 138 age values, and we are dividing the data based on that. However, if you want to increase even the further efficiency, what we can do, we can even apply the binning technique. So what binning does, it actually divide the age into multiple groups, and based on that groups, we actually feed the information into the machine learning to get the outcome, right? So that's where we really go deeper and start, improving the outcome of our prediction. But in this case, I think we are good. Working class. Now, with working class and even with the gender, these variables we normally call in the stats term, they are the categorical variables, because you can see they have the discrete value or the limited value that you can count them, and they are referring more like some defined categories, right? So even I can show you if we actually. Let's see the distinct work class, and we'll see how we can, handle that data once we apply the feature engineering. So what I'm going to do, I'm just going to apply the distinct to see how many worker classes we have. So you can see we have almost 7, and one of them is the unknown class, or I would say there are data issues that we can obviously fix. It depends upon how we're going to actually approach this issue. There are multiple approaches. We can even work with business to get the information for the missing data. We can even recommend or we can predict the value of the missing values where the gaps are, right? So we literally use machine learning to fix the quality of machine learning data, right? Put this way, it really depends upon what scenarios we are dealing with. So we have 7 values, and you can see we'll now in this video we're going to see how we can handle the categorical data before we run the logistic modeling. Right, so next we have the marital status, and marital status is also the categorical variable. You can see we have bunch of marital status. We have occupations as well, and again similar way we have bunch of occupation. And I think in the occupation we have missing occupation as well, like you can see. So the whole data has the quality issue, right? So that's one of the biggest challenge in the industry, that you have heard on and on, that okay, the quality is impacting the data science and machine learning work, because obviously you feed garbage into your model, you're going to get the garbage out from your model, right? And that's where most of the efforts has been placed while we are working in the machine learning and the data science environment. All right, so right now, we can see we have even there are some more issues, like you can see in the occupation, one occupation is coming twice, and there is a reason, because there is a space in the sales value, and that's why the group by clause is taking sales into two rows. So these are all the data quality issues. So the good thing, like you can see, we have all these issues now apparent. And the similar way you can see we have these question mark which are coming multiple times. The rationale is similar. Like you can see, we have the missing data, and obviously that's gonna impact on the quality of your data, the outcome of your model. So with this operation, at least we can quickly sense check, and we can sometimes, sometimes the data errors, they are acceptable by the business because they know, or their presence are so low that their impact on the final outcome is minimum. So business normally, approve these kind of error, that yeah, the ratio of the error data compared to the actual set is so low that you can safely ignore it. So in those instances, we normally run the model with these error records, because the impact of these records on the overall accuracy of the model is going to be very low. Right, so just keep these points in mind. That will help you to build your knowledge, that once you get the job, what factor you're gonna keep in your mind, and once you get the accuracy or prediction, how you are going to improve it, and what are the ways to improve the outcome of your model. All right, the next one is race. And you can see race is, I think we have 10 rows. Race is pretty clean data, like we can see in here. I think so far the worst we have seen is the occupation, because it has a couple of dirty records where we can see question mark, and we have a typo as well. Marital status is good. Like marital status, we cannot see anything. And similar way, let me see, with the working class, we have the similar issue. It is also dirty as well. Like you can see, we are getting multiple values. Okay, and I think, yeah, there are the typos as well. Like you can see that federal is coming twice, and there is a space issue in there as well. Okay, let me just see if I can fix it quickly before we move on, because that will help us. So how about if I use stream, and I'm going to order it by, let's say 2. And 2, normally once we mention the numeric with the order by clause, it actually count the column position and sort it based on the position. So what it's going to do, our first position is total, which is the total count, and then we have the class, and then we have the third location is working class, which we are trimming. So let's use the third position, right? Because we want to arrange the data. So now you can see we have the federal dash gov. No, I think the repetition is fine, because we are dividing. Sorry, I think that's where I did a mistake. We are that's all good, because what we are seeing in here, it should repeat it, because we are grouping it by the class as well as the work class. So that's all good. Yeah, because one row is representing greater than 50K, the other one is representing less than 50K, less than and equal to 50K. Sorry, my bad. All good in here. The only issue so far is with the question mark, that we have some gaps in our data. All right, so we have seen up to the race. Now we have the hours per week. And based on the hour per week, we can see that we have number of hours the person is working within a week, and that is going to help us to determine whether the person is going to earn greater than 50K or less than equal to 50K. So that's another good attribute that we can use. final weight, that column we are not going to use it. I forgot to check what this column means. I think up to this point we have enough columns that we can use to predict the working class. But obviously, I tell you as a rule, more relevant column or feature that you can include in your model, it's going to impact on the accuracy of your model. Like it's going to improve the accuracy, right? But make sure all the features you are including, they are relevant. And obviously in the last video we have seen, we can use the correlation function or to find the relationship between the feature and the final outcome. If the correlation is high, we can use it. If the correlation is very low, that means you can obviously ignore it. So for example, I'm not considering in this one the capital loss or capital gain, and as well as let me see what else I'm actually ignoring. Yeah, I'm just ignoring these two because these two are not going. You can see most of the values are 0. So the correlation between those two columns and the class is going to be very low, right? So they're not going to be significant while I'm going to feed them into my machine learning model. All right, so I think we are pretty good from the dataset perspective, except we have a couple of missing entry. Now, the next step is obviously the biggest challenge in front of us, how we are going to convert our numeric textual data or categorical data, whether it's going to be in the form of text, or even it's going to be in the form of numeric, excuse me, how we are going to convert them into the numerical way that it can benefit our machine learning model, and how it's going to be settled down in a way that it can easily feed into the linear regression model. So in order to do it, what we're going to do, we have a very famous technique and that works really well, and I'll let you understand that first before we proceed with the further execution. So let me reshare my screen. I've already prepared a demo. Yeah, and that technique you can see we called it OneHotEncoding. The technique is very simple, very efficient. If you have a computer science background, you can easily understand, because we normally do these things to cater most of the value at the binary level. So binary means you only have two values, either it's going to be 0 or it's going to be 1. So like you can see, I just took one column value and sorry, one feature values, which is categorical, and that has the marital status. And you can see we have 7 status. So if you can see in here, and what we normally do as a first step, we actually index them. And that's where you're going to see I'm using the string indexer. What string indexer does, it index the string value, and it starts from 0 to n minus 1 value, or it starts from 1 to the number of items. So in this case, it's going to assign a never married as 1. The next value is going to be 2, the third one. So that's more like it is converting them into the key format, right? So you can see we have a key against each value, which is unique to that value. All right, now what OneHotEncoding does, and that's where you remember I told you sometime we have to feed millions of features. So you are going to see how quickly the features number of features increase once we build the real machine learning model. So now, based on that, I know I have the 7 categories. So what OneHotEncoding does, it actually create a list of value which has 7 values in it, right? So whatever the value is present in the record, only that value's place is going to put as 1. So you can see that obviously the first value index is going to be 1. The second value index is going to be 2. The third one is 3, 4, all the way to the last one. All right. So now, if I have the value in my record is never married, so that means only the first index, that is going to be 1, and then the rest of the values are going to be 0. So once we build our feature, we are going to have 7 additional columns in here. And by the way, we can reduce it to 6 because always the last value, if not all the values are going to be present. So that means obviously it's going to be the last value. That's more like a logical thing. But that's how we can reduce the number of columns, which obviously impact the performance of executing the machine learning algorithm. Right. So in this case, you can easily understand never married is because we have the value of never married. We just put 1 against it, and the rest of the columns are going to be 0. And obviously, maybe in the next record we have the divorce. So what are we going to do? We put 0, 0, and because this value is active, so we are just going to put 1 against it, and the rest of the values are going to be 0. Now, how we represent these values? Obviously, if you remember, we end up in converting these values into the vector format, or which is, like I mentioned, always it's going to be the list of value or the array, because we haven't discussed the array, so I'm not actually using that concept. But you can remember that is the list of value or the array, right? So we are going to obviously convert this value into array. So whatever the one hot encoding we are going to use, we convert it into the array, and then that array feed into our model. Now, how we represent it once we convert it into the vector format? So the very first position, like I mentioned, it shows the total number of encoding, and like I mentioned, we always take n-1. So if we have n values, we are always going to take n-1 value, because obviously if the value doesn't sit within the n values, n-1 value, then obviously it's going to be a last value, right? So in this case, we can reduce one place or one column, right? So you can see we have total 7 values. So the vector is going to represent as 6. Then obviously we have I think in this case, let me just change it to 1. That's going to be, yeah, because our first value is active. So we are just putting that the first cell is going to be active, and then the value is going to be 1, because obviously it can be either 1 or 0. Right. So that's how we represent it in the vector format. Now let's go back and apply the same rule into our actual environment. Okay, we are back into our environment. So very first thing you can see, I'm using exactly the same thing, string indexer that we have discussed in the Excel file. And what it is going to do, and I'm going to show it to you. String indexer, it takes the column and it asks for the what kind output column it's going to use to place those indexing values, right? And then obviously we need to call it give us the object that has the transform function. We feed our data frame in it, and then it will return us the data frame with the additional column which has all the index of the categorical column. So in this case, we're going to have, once we run this outcome, we're going to run this cell, we're going to have the outcome where we have the word class as well as the word class number, which is representing the indexing of the word class. Let me show it to you. So now you can see we have the word class, and we have the word class number. Just to show you that what the sequence is going to be, I'm just in the next cell, I'm going to only select these 2 columns. And if you remember, we discussed these statement in our PySpark videos. If you don't understand, please watch those series. That will really help you to to understand how we manipulate the information using PySpark, or even Scala or SQL, right? Because that's where the power actually sits. So I'm just selecting these 2 columns. So, and I'm just going to get the distinct, and I'm going to order it by worker class number. I can convert it back into the data frame, but obviously that's going to be too hassle for me to to switching back and forth between SQL. But just for your interest, I'm just going to show you, if I write the select statement for it, what it looks like. It's going to be select word class, obviously from, and we have VW adult, right? And I'm going to, because I'm going to select this thing, and I'm going to order it by word class number, right? So the same thing, like we can transform, and we can, by looking at the data frame, we can write our own select statement, right? So that's the beauty of using the DataBricks, a really great way to handle the big data and the machine learning workload for for modern enterprises. So now let me run it, and I'm going to show it to you. You can see it's starting from the indexing from 0 now, and obviously if we have 9 values, it's going to actually return us the index from 0 to 8, right? Now obviously now we are going to, so we have now indexes. Like I mentioned, the next step is creating the vector format, because the vector is going to be fed into the machine learning model, and we have discussed that concept in the linear regression as well. So if you have any confusion or you need a refresher, please watch those videos as well. I'm going to put the link of the full playlist in the description, so if you want, you can go and you can watch those videos as well. All right, so what we are going to do, like you can see, we have indexing, we have applied the indexing. Now the next step is applying the, so all the languages like PySpark, Python, and any other machine learning language, they are providing the function for one-hot encoding. And all we need to actually provide the column on which we want to apply the one-hot encoding, and obviously as usual the result column, which is obviously going to be a vector, like we have discussed in the Excel file. So obviously it will return us the encoder function, and encoder function will ask us to provide the data frame so it can fit it. So these are the internal mechanics that how we normally do the one-hot encoding. And it's more like a learning thing. You can just understand this function, that it first fit the data frame and return us the encoder, and that encoder has the function which actually take the data frame and it convert it, convert the numerical value in the vector format, and that's what it's gonna do for us. And now let me run it to show you the vector that we have explained. So you can see we have 3 value vector, and I've actually explain how it has been converted based on the categorical numerical value. It has been created based on the second last column. So word class vector, that is not created based on the word class, but it has been created based on the word class number. And you can see, let me quickly show you how we can read it out. So we have total 9 values, 3, 4, 5, 6, 7, 8, 9. So we are going to use 8 because, like I mentioned, it's going to be, these are going to be the number of features, right? So if we reduce 1, it obviously improves the performance. Now 8, and on the 4th position, if you remember the Excel file, on the 4th position, we have the value 1, right? The rest of the values are going to be 0. So if I look at the value, what value we have for my working class, the guy is working in the state government. Now let me see what index the PySpark assigned to it. For the state government, you can see it has assigned 4, right? So that's how you can understand the vector class once it has been created for you, right? So that's a very powerful technique for handling the categorical data. Obviously we're going to see later on, once we have the continuous data, if we can manage those data sets as well. But most of the time, you can now see that how you can convert those values which are coming in the categorical fashion, and how they can improve or put their input into your machine learning model, right? So similar way we have, like I mentioned, now we are going to apply the same thing on marital status. And you can see this, that's the example we have discussed. We have 7 values, right? So index is starting from 0 to 6. Now, same operation we are going to do. And now let me show it to you, right? You can see 6, 1, 1, right? And 1 is in here, never married. And that's the one that we have used, right? So you can see never married, and it is, easy to understand. So once one hot encoding is beautiful in a way, once you understand, everything makes sense. But if you don't understand the underlying concept, it's very hard to, to describe what hot encoding does, right? So let me just run for all the remaining one up to the point where we ready to assemble our vectors for our modeling, just to show it to you. Yeah, so I think up to this point, relationship number, we have relationship, and you're going to see we have in this data set at the end, we are going to have a lot of features, because obviously with all these categorical values, we are going to increase the number of features, which is going to fed into the logistic regression model. So race vector, we have feed converted, gender, we have converted. Obviously, these are the repetition tasks that we normally do, because obviously once we understand one technique and all those columns where we have those technique, we apply this technique, similar technique to all those columns which are coming under the same category. So then we have the native country. And I think native country is the last one. And now you can see how quickly the data frame is growing. And obviously, like I mentioned, in the real environment or in the real businesses, sometimes it span on hundred thousands of the columns, or even sometime close to million that we use. But obviously we have different algorithms, we have different techniques that we can use to handle those kind of workload. But base start from here. Remember, once you have good basis, you can apply the same technique to any kind of data with the volume, or with the width. So now everything is done. What I'm going to do, so now all I'm interested, because I've converted all this vector, I'm only interested into the vectors which I've actually created. And now let me just show you all the vectors which have been created. So you can see we have vector work class vector, we have marital status vector, we have occupation vector, we have relationship, we have race vector, we have gender vector, and we have native country vector. So these vectors are going to be used for our machine learning model. So in the next one, as a last step, I'm going to show the final schema of my class. So you can see we have all these vectors which are coming now with their corresponding column, right? So up to this point, our data set is ready from the feature engineering perspective. There's only one issue which is left, which is converting the column from the string value into the numerical format, because obviously we need to feed these classes back into the machine learning, so we can get the outcome based on those classes. So hopefully we'll in the next video we'll convert that, and then we are ready to feed the data set into our machine learning model. I do believe this video is going to be helpful for you to understand the encoding and the feature engineering, which is a very important step for machine learning and data science activities. So thanks for watching. If you have any questions, please post it into the comments. Otherwise, please like the video, and I'm gonna see you in the next one with the linear regression execution. Thanks for watching.